Welcome back to Educator.com. Today we will be discussing the basics of lighting. This is part 1 of a 2-part lesson. Let's begin. In this lesson, we will discuss how light is defined and categorized. And to that end, we will describe the different types of light as we define them. We will also answer the question, how do we quantify and qualify light? How do we measure the light? How do we describe it? This includes intensity, contrast, shadows, and color. Light defined and categorized. Before we really get into discussing how we define and categorize light, let's ask the question, what is light? Well, light is energy. This is an important thing to remember, especially in terms of how the camera is interfacing with it and the lens. And we're going to discuss light in terms of the wave theory of light, and that light travels as a wave. And so then we need to ask the question, well, how do we qualify this energy that travels as a wave? How do we qualify it? And also, how do we quantify it? So qualify is how do we think about it in terms of its quality? Because we can think about light in many different ways, not just there is light. There's lots of different ways we can think about the light and qualify it. And then, of course, there's ways that we quantify it, which means measure it. So the 3 main categories of how we're going to qualify and quantify are in terms of its directionality. So light always has a direction. Its intensity, which is how much light there is, and its color, which speaks of where it falls in the color spectrum. Okay, so types of light. There's 2 main ways that we talk about light in terms of the type of light. There is the directional light and diffused light. So when we talk about directional light, just to give you a sense of it, we're talking about light that we can aim without much spill. Light that is directional creates very distinct shadows. And I want you to think about directional light as headlights on a car. Diffused light is just when we talk about more of a general illumination coming from some source. It would have more transparent shadows, and we would talk about it in terms of having slow fall off. And we're going to talk about what fall off is a little more distinctly in a little bit. But these are the 2 different types of ways that we categorize light. And depending on the day, the sun, your source, can serve as a very harsh directional light with not much spill, distinct shadows, or if we have an overcast day, those clouds create like a silk in front of the light. The sun is the source, and the clouds diffuse it. Or another word that we call it is called scatter the light, which creates more of a general illumination, transparent shadows with slow fall off. So again, we want to start thinking about every light, in terms of the source, and whether it's directional or diffused. And this way we can better control it. Okay, light intensity. Light intensity is the way that we actually start to quantify it or measure it. So light intensity refers to how bright is something, how much light is falling on an object. So it's how much light falls on an object, and it can actually be measured, just like water can be measured and distance can be measured. How much light falls on an object or on an object or a person can be measured in terms of foot candles or lux, which is also lumens. So foot candles is the amount of light. So we're going to define it now. Just like we defined how long is an inch, we are now going to define the foot candle. A foot candle is the amount of light falling from a candle on 1 square foot area located 1 foot away from a candle. I have no idea how they came up with this, but this is how we decide how much light is falling on an object. It's this quantity of light. So you also should just be aware of lux, because you'll hear both terms being thrown around. Lux or lumens is going to be a larger amount of light. It's the amount of light that falls on a surface that is 1 square meter. Just depending on which system you're working in, you may come across both. Another term that I want to familiarize you, you'll hear on sets, is base light. So base light just refers to the overall intensity of light in a space. So the thing about video cameras and film cameras, or film stocks, is that you need to have a certain amount of light, base light, in order for you just to get a proper signal, a broadcastable, usable signal. And so therefore you'll hear people talk about, is there enough base light? Is there enough general illumination for me to get a proper signal, a proper video image? So is there enough base light? You won't get a strong enough video signal if you don't have it. You must, if you don't have enough base light, you must increase the overall intensity, or another trick or another approach would be to increase the gain of the camera itself. When you do that, though, it's not the best solution when you don't have enough base light, but it means you're actually increasing, you're kind of forcing the sensitivity of the camera itself. Okay, so measuring light intensity. There's two ways to measure how much light is hitting an object. We have incident light, which is light that is falling on the object. And as you know, when we see something, it is because light has fallen on the object and it's reflecting back into our eyes. That's how we're able to see, and that's true for the camera as well. So the incident light is the amount of light that falls on the object. And then the reflective light is how much light is bouncing off that object and coming back to the camera or your eye. So different type of light meters measure different, are needed for each method of measuring how much light is either falling on the object or coming back from the object to the camera. So we've got incident meters, which measure how much light falls on an object, and spot meters, which you hold by camera and you would point at the object, and then you're able to measure how much light is actually reflecting back from the object to camera or to your meter. Most director of photographers, cinematographers, lighting people will use a combination of both of those type of meters to be able to better control their lighting. So now let's talk about contrast. So contrast is a quality of how we've lit a scene, and it's important for us to really define what is contrast. Okay, so contrast is the difference between the brightest areas, which we will also call the highlights, and the darkest areas, which is called the shadows. So when we talk about contrast, we often will talk about contrast ratios, and we actually measure and we can find out what a contrast ratio is in a scene. You should know that video cameras, the modern ones, are getting better and better at this, but sometimes video doesn't like a lot of really intense contrast or high contrast ratios. So we like to measure and control it. So what we would do is we'd actually be using a reflective light meter, and we want to measure the reflective light from standing at a camera. So remember, to find the contrast ratio, we use the spot meter in order to get the reflective light. We point at the darkest area, the shadows, and then we point at the lightest areas, which is the highlights. And this will, when you take the measurement, you can get a contrast ratio. Your shadows to your those two numbers, you are able to get a ratio. The higher the contrast ratio, the higher the apparent contrast is in the scene. Now again, some cameras, and sometimes just creatively, you don't want high contrast. So in which case, what you want to do is you can lower your contrast, and there's three ways, really quick, easy ways to do that. The first would be to increase your distance from your lighting instrument, which is your lighting source, which could be your lights or natural light coming from a window. So increase the distance from the lighting instrument to the object. That's going to decrease your highlights, essentially, thus decrease your contrast ratios. You could also put diffusion in front of the light, or another thing is to just dim the light with your electronic dimmer. Now, one thing about dimming lights with a dimmer for you to think about is that every time you do that, you're going to change the actual color temperature of the light. And we're going to talk about color temperature in a bit. But that can create some problems in terms of having mixed light sources if they all have different color temperatures. But if you're just dimming it a little bit, you may not be setting it off the color temperature too much, and that can be a good thing. Okay, so let's think about contrast a little bit more. I know a lot of people, when we first start working with cameras and photography and cinematography, contrast is not super clear in their minds what it is. So the difference, again, remember, contrast is the difference between the brightest areas, the highlights, and the darkest areas. And I have two images here. They're the exact same image that I have adjusted the contrast in post. And you'll notice that this has higher contrast ratio, and this is lower. So the difference between my brightest brights here and my darkest darks, there's more of a difference than over here. My darkest darks and my brightest bright are closer together in terms of the amount of light that would be reflecting back off those objects. Shadows. So I've been talking about highlights and I've been talking about shadows. And one thing we want to do is start to think about our shadows, because we want to control our shadows for lots of obvious reasons in terms of the imagery that we're creating. So let's define what types of shadows are there and what their function and their goal is when we look at an image and when we light our people, our subjects, and our spaces and our objects. So we've got two main kinds of shadows. We've got attached shadows and cast shadows. So in the attached shadow, that's the shadow that is actually on the subject. So in case it would be my face. So any shadows that might be around underneath my eyes or underneath my chin or on my neck. So attached shadows are shadows that are actually attached to the object. When I say object, I'm also referring to people, subjects. Attached shadows are never independent. When the object or the person moves, so does the shadow. These are really, really important. The attached shadow is what actually reveals the form, the depth, and the texture. They define the object. They allow us to figure out, our brains to figure out what we're looking at. It's those attached shadows. Okay, now cast shadows, another type of shadow that we also control as cinematographers, is they are independent from the object. They define spatial relationships. So we have a sense of distance and angle from one subject or object to the other. They can also indicate time of day, if it's a long shadow versus a short shadow, that tells us where the sun is in the sky. And they can be, just like with the attached shadows, they can also be dense or transparent. So let's take a look at some of these shadows. Okay, attached shadows. So here we are. We've got shadows that are attached to the object. They're never independent. They reveal form, depth, and texture. They define the object. So here we are able to figure out that this is a face because of and get a sense of the face because of these shadows here. There's a shadow here. It's more, it's a little bit thinner, and here. Okay, and then we have some highlights here. But those are all attached shadows. So now let's look at some cast shadows. So this is a favorite image of mine. So we've got some cast shadows here of this penguin here and here. And that tells us that the sun is somewhere over here to their right or screen left. So again, they're independent from the object. They define spatial relationships. They indicate time of day, and they can be dense or transparent. Okay, so another term that you'll hear is fall off in terms of shadows. So again, fall off is a term that you'll hear, oh, it's fast fall off, or you'll hear slow fall off. So it's the degree of change from the highlight to the shadow. Fast fall off is abrupt change from the light to the dense shadows, and sharp edges or corners are often therefore implied or are present. Slow fall off is more continuous change from the light to the shadow side. It's gradual shading, and it indicates often a curved object. So let's look at a couple of examples just so you can understand what I mean by that term. Okay, so here we go. This is the Anza Borrego Park Preserve, and we've got some fast fall off going here. So these shadows right here, right next to that highlight, and that tells me that these ridges of this formation are very sharp. And they actually are quite sharp. It's difficult. You wouldn't be walking along here. It's so narrow and thin, and it falls so fast if you're actually in this space. And then over here, we've got some slow fall off. And these forms are much more gentle, curved boulders. And you can actually see the curvature of the forms. And the highlights move much more gradually from the shadows move much more gradually from shadow to highlight to give us the indication of that rounded form. All right, so let's move on to color. It's another way that we qualify light. And when we make our images and video, we're always talking about color. And as you know, white light has a whole bunch of different, has the spectrum of colors within it. But even within our white light, we still need to talk about color and color temperature to better understand it and to control it. Okay, so in film and television, we are talking about additive primary colors, which is different than when we paint or draw pigment colors. So this is called additive primary colors. You'll hear it's RGB. Those are the primaries. So we've got red, green, and blue. The RGB create our white light. So all colors of the spectrum make our white light. And just to be clear, when I'm saying additive primary colors, as opposed to our subtractive color mixing, is for our pigments, which would be the red, blue, and the yellow. And that's what most people, when they come into video, that's what they're thinking. But we need to shift our understanding of the color theory in terms of light is mixed differently. It's the red, the green, and the blue that make the white light. And just to kind of give a little bit of background, so when we think about video, we're actually generating these colors with an electron gun, the TV or your color monitors. That's what we're doing. So we're taking our primary colors and we generate them, and depending on how much red, green, or blue is present, that's how we define the color of the light that's being emitted. Okay, color temperature. So just like with intensity, we have a way to measure it. We have a way to measure color. And this can get just a little bit confusing in terms of the language, but we'll get into it. So color temperature is measured in kelvins. And blue light is actually higher in kelvins than red light. Red light is lower, and we talk about light being rated. So it's rated as less kelvins. And generally speaking, 3200 is our indoor light instruments, our incandescents and our tungsten light instruments. And 5600 is generally speaking our outdoor light, our sunlight. However, as we're going to look at this chart in a second, outdoor light can be way hotter than that, and indoor light can actually be way cooler than that. So now I'm using these words, cooler and hotter. And now I'm talking about looking at the light, the feeling of the light. But actually, if I say, when I say cooler and hotter about bright light is actually hotter, I'm talking in terms of kelvins. There's more kelvins. But when we look at blue, the color blue is cool to the eye. And the color red is warm to the eye, but it's actually rated as less kelvins. So it's actually cooler. If you were to touch it, it would be cooler. So this is something that folks have to get straight in their mind. When we talk about light being hot and cold or cooler, are we talking about how it's actually rated, or are we talking about what it appears to the eye? So again, indoor light is 3200. So it's cooler in terms of, or it's less kelvins, and outdoor light is bluer to the eye, but it's actually higher to the Kelvin rating. Okay, so another really important component to video production and light and color light in terms of dealing with color is white balancing. So while white light is all the primary colors mixed together, there's still a spectrum of what we consider white light. And it can be warmer to the eye, be rated more at 3200, or white light could be rated at 5600 kelvins, which is bluer in appearance, but again, hotter in terms of kelvins. And because not all light has the same whiteness, we need to tell the video camera what we're considering our standard for white light, and then all the other ratings of light, the color temperatures, will fall in relationship to that. So what we do is we adjust the camera so that it reproduces a white object on screen as white in the white light that we're using, regardless of the color temperature of the bulb illuminating it. So that's a very important part of the process. And if you do go ahead and you're white balancing your camera, I want you to just remember that it's an important part of your process. You must do it every time or have an automatic setting so we know what we're working with color temperature wise. Thank you very much for watching Educator.com.